Okay, so you are going to complete the Lewis structure for the following molecules. So C2, H3, O2, -1. So I want you to complete the Lewis structure for this compound. This is the acetate ion. So carbon, 2 carbons bring total of 8 valence electrons. 3 hydrogens bring 3 valence electrons. 2 oxygens bring a total of 12 electrons, and a -1 charge brings 1 electron. So we have a total of 24 electrons to place. So we know that carbon has the highest combining capacity, so it's our central atom. We know that it makes 4 bonds. So we could try doing this. So we've got 3 hydrogens and only 2 oxygens. So we know that we don't have this 3rd bond. So we've placed 2, 4, 6, 8, 10, 12 electrons. So that leaves us with another 12. So 12 electrons in the bond leaves 12. So you put them around the terminal atoms first. So 2, satisfy their octet first. 4, 6, 8, 10, 12. So now oxygen is surrounded, each oxygen is surrounded by 8 electrons. So we've used up our 12 electrons, we have none left. So let's double check our central atoms. Carbon number 1 is satisfied, it's surrounded by 8 electrons. But carbon number 2 is only surrounded by 6 in the bonds. So we don't have any more electrons, so we have to make one of those lone pairs of electrons into a double bond. It doesn't matter which oxygen you use. You bring it down so that it forms a double bond. So then you end up with CH3 with a double bonded O. So now we have 2 lone pairs of electrons left, and we have 3 lone pairs of electrons on this oxygen. So we've used We've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons. Carbon has 4 bonds, carbon has 4 bonds, oxygen has 2. Oxygen doesn't have 2, but it has more than, doesn't have more than 2, and each hydrogen has 1. So our combining capacities, number of electrons are okay. We have to put a bracket, square brackets, and the charge on it because it is an acetyl ion. Now to do acetate from this formula is hard, but normally organic compounds, carbon-based compounds, actually give you a hint to the order of the atoms based on the order that they give you in the compound. So this would normally be written, or alternately be written as CH3CO2. So what this is telling you is that the first carbon has all the hydrogens bonded to it, and the second carbon has all the oxygens bonded to it. So this kind of gives you a hint about how the bonding works. or rather where the atoms are actually attached to. Okay, I want to show you, now that you know the basic steps to writing your Lewis structures, I want to show you an alternate that works for most cases. And it's called the TVS method. TVS method. Okay, TVS method. So T stands for total electrons wanted. So each atom has this many electrons around it when it's full. V is the valence electrons brought by each atom, and then S is the electrons that are shared between atoms in bonds. Okay, so if we did the acetate ion again, CH3CO2 negative. We've got 2 carbons, 2 oxygens, and 3 hydrogens, and a negative charge. So the total wanted, each carbon wants to be surrounded by 8 electrons. So 2 times 8 is 16. So carbon wants 16. To this we're going to add the other number of electrons that are wanted. Oxygen wants to be surrounded by 8 electrons. 2 times 8, because there's 2 oxygens, is 16. Hydrogen, on the other hand, only wants to be surrounded by 2. 3 times 2 is 6. So in total, we want 32 plus 6 is 38 electrons. So T stands for total electrons wanted around all of the atoms added together. V is just like we did. V is the number of valence electrons. Well, carbon brings 4 electrons. There's 2 of them, so they bring a total of 8 valence electrons. 2 oxygens. Oxygen brings 6 electrons. There's 2 of them, so we bring a total of 12. Hydrogen brings 1 valence electron. There's 3 of them. So we've got 3 valence electrons. And then the negative charge. So 8 plus 12 is 20, plus 3 plus 1 is 24. So we only have 24 electrons to work with, but we need to make this to appear to be like 38 electrons. So shared. To figure out the electrons shared, what you do is you subtract 24 from 38. So that's 14. What you do now with this means that there's 14 electrons that are shared. If you divide that by 2, because there's 2 electrons per bond, we get the number of bonds. So there's 7 bonds in our structure. So if we put in our hydrogens and our carbons and our oxygens, we have only placed 1, 2, 3, 4, 5, 6 bonds. We know there's another one. The only way there can be another one is if there's a double bond. The first carbon can't have the double bond because it's bonded already 4 times. So the second carbon has to be the double bond. Now it is bonded 4 times. So now we know we've placed 7 bonds for a total of 14 electrons. Subtract that 14 of electrons used in our bonds from the number of valence electrons provided, which was 24. We've got 10 electrons left to place. Carbon doesn't need any more. Hydrogen doesn't need any more. This carbon doesn't need any more. This oxygen does. It needs 4 more to make its octet 8. So now we're down to 6 electrons. And this last oxygen has 2. It needs another 6. There's our last 6 electrons. Gone. Put it in square brackets. 1 minus. We double check. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24 electrons used. Everybody is surrounded by the correct number of electrons. So everybody has 8 except for hydrogens that have 1. Put a 1 negative charge. Good to go. Done. So this way is actually a little bit easier than the other way because it gives you a hint. This figuring out the number of bonds gives you a hint as to how the atoms are arranged. Okay, so acetic acid. Let's do the TVS method for this. It's similar to the last structure we did. Total, we've got 2 carbons that require 8, that want 8. We've got 2 oxygens. They want 8, so this is total that they want after bonding. Then we've got 4 hydrogens, and each wants 2 total. So if you add this up, it's 32 and 8 is 40 electrons. So it wants to appear like there are 40 electrons. Valence electrons. Well, carbon brings 4. Oxygen brings 6. Hydrogen brings 1. So 2 times 4 is 8, plus 12 is 20, so that's 24 electrons. So shared is the difference. So now we're talking 16 electrons, or 8 bonds. So our structure contains 8 bonds. It's very similar to the last one we did. Each carbon can have 4 bonds. Now, remember the last one didn't have its combining capacity for oxygen? That's where the other H goes. We've got 8 bonds, so let's check. 1, 2, 3, 4, 5, 6, 7, 8 bonds. So we've used a total of 16 electrons. Take it away from our 24 valence electrons. That leaves us with 8 left. Carbon satisfied, surrounded by 8. Hydrogen satisfied, surrounded by 2. Oxygen is not, so let's put those on. This oxygen up at the top needs another 4. So 4 electrons left to place, and this one needs 4. So now we have none left to place. Everybody's octet is complete. Everybody has their combining capacities, and there we go. There's our structure. So let's do another one. Let's do HCN. So TVS. Total. Hydrogen wants 2. Carbon wants 8. Nitrogen wants 8. So we want to have a total of 18 electrons. But we only have 1 plus 4 plus 5. Hydrogen brings 1, carbon brings 4, nitrogen brings 5, for a total of 10. So shared, the difference between these two, 8 electrons. So HCN, put your bonds in, that uses up 2 bonds. We've got a total of 4 bonds. Carbon can take 2 more bonds. Nitrogen can take 2 more, so let's put them in there. So now we've used the 4 bonds, 3 on one side of carbon, 1 on the other. We've used then 8 electrons. That leaves 10 minus 8 is 2 electrons. Carbon's happy, it's got 8. Hydrogen's happy, it's got 2. Nitrogen only has 6. That's where our 2 electrons go. There's your Lewis structure. So there are advantages to using the TVS method as long as it is applicable.